In this video tutorial, we are going to see how to download SRTM DEM from Google Earth Engine. So this SRTM DEM is being given by NASA. So it is called as NASA at a SRTM DEM with a resolution of 30 meters. So now, first let us choose our study area. So in order to choose our study area, I am going to use this option, draw a rectangle, and draw a rectangle for choosing my study area. Now I am going to use mouse left click and draw a box like this. Once I have drawn the box, I can once again use mouse left click to finish it. Now once again click on exit. So after defining our study area, you can see at the top in the imports, this boundary has been taken in the imports called as variable geometry. It is a polygon of 4 vertices. Now we are going to define a variable here down. Variable, I am giving a name for it. For the study area, I am just dividing as AOI. So this is just a name. So I am just telling that my area of interest or my study area is equal to geometry. So from the imports, it will be taking this geometry. You can change any name here also. Instead of geometry, you can type in polygon. But here it should reflect here. That has to be kept in mind. Same name should be given here also. Now the next steps is we are going to load the NASA SRTM 30 meter DEM. So you can see the image collection. So in order to load it, I am defining another variable called as SRTM 30. This is just a name. So after that, I am going to give the image collection from where the image has to be taken. So you can simply search in the search bar for the NASA SRTM DEM. So like this, you can search for the NASA SRTM DEM. So you can see the results are coming up over here. If you want, you can also search for it separately. So you can find that in the top, NASA SRTM digital elevation 30 meter. If you click on it, you'll be getting to know more about this image collection. So this is a 30 meter resolution DEM, 30 by 30, and it is being provided by the NASA JPL. You can also check for the bands. You can see here the minimum and maximum and resolution, and in what unit it is being given. It's in meters. So likewise, you can directly copy it or you can directly click on import. So in this case, I'm just copying the image collections. You can paste it here in the image collection. Now after that, you can see the next thing is that we are going to clip the DEM based on our area of interest. So you can see the polygon which we have drawn here. So we are going to clip the DEM only for this region. So for that, I am defining a variable called as NASA SRTM clip. This is just a name, and I'm just giving is equal to NASA SRTM 30 dot clip. So here the clip functions cut the bigger DEM to a particular area. For example, our area of interest. So we'll be getting the DEM for our area of interest by using clip. Otherwise, it will be we'll be getting a larger area. After that, we need to be clipping that separately. So here also we are just defining it. So to clip it, followed by that, you can see we have defining the color for it, minimum and maximum values. So the minimum and maximum values differs. For if you have a good knowledge about your region, you must be knowing the maximum elevation of your area of interest. So based on that, you can give the maximum value. Right. After that, we are going to assign some colors to the DEM, outcome DEM. So you can see I have used some color codes here. Each color code has its colors. You can't find the color what it is indicating, so I have given it separately. Now if you come down, the next step is we are going to display the map on the Google Earth Engine. So for that, I am using, first is we are going to center it. So I am going to use the function map.centerObject. So the map will be centered based on the AOI, that is our area of interest, and you can see the zoom level. I have just kept it at 10, you can increase it or decrease the zoom level. Followed by that, we are going to add the layer. Add it as a layer. It will be available here under layer section. So for that, you can see we are using the clipped SRTM data, and visualizing parameter, it will be also being given. And finally, we can name we can just give a name for the layer which is coming up over here. So I just defined it as NASA attached SRTM 30 meters DEM. And after this, we are going to export this DEM data to our Google Drive, and followed by that, we are going to download it and we'll be just visualizing it in GIS platform. Now in order to export it to Drive, I am using this function export.image.to-drive, and you can see the image which you are using is SRTM clipped image, which we have already defined at the top. We are clipping the SRTM DEM, and you can see the description is nothing but I am just giving a description for it, SRTM 30 meters, and you can choose the folders where it has to be saved in the Google Drive. So you can change it. So in this case, I have given ge_exports. You can change it accordingly. If you have created any folders in a different name, you can just replace it here. Next is the file name prefix. So I am just giving the file name as NASA SRTM 30 meters, and followed by the region is our area of interest. Scale is 30 meters, right? And followed by that, you can see here I have given the CRS coordinate system, so EPSG 32643, and it is also called as UTM zone 43N. This is a projected coordinate system. You can change the projected coordinate system accordingly based on your area, or you can use the geographic coordinate system 4326. But for doing any kind of analysis laterly in your GIS platform, you have to change it to a projected coordinate system. So you can see here maximum pixels, that is nothing but we can export up to 1 trillion pixels. So just in case, I am using this function. Now after that, we are closing it, and let us run the code. So you can just see here the results are coming up. So once it is done, let me remove this polygon, and you can have a good look at the image collections. You can also use the inspector tool to inspect the heights of the region. You can see 2325 meters. If you click somewhere over here, you can find the height difference. It is just 114 meters, right? Here in the layers, you can find NASA SRTM DEM 30 meters that we have given here. You can also customize it. You can add or remove the color schemes, or if you want, you can edit the colors also from here. You can choose it accordingly, and after that, click OK and apply and import. So study area in a different way. For example, in this case, you can see here I'm having some shapefiles uploaded to this Google Earth Engine assets. So in order to get the DEM for our study area, first we need to upload it. So I have already made a video on it, how to upload shapefiles to Google Earth Engine. So in this case, you can see here I'm having a shapefile. I want to import it, and for that I need to just get in the DEM data. So I'm just going to click here so that the shapefile will be imported. As you can see here, variable called as table. So this shapefile is been a variable, taken as a variable, and it default name is table. You can change it to, you can give it any name for it, study area likewise, and followed by that we are going to change it over here also. For example, we are going to just say, instead of the rectangular, we just need to do it for study area boundary. So let me copy this and paste it over here, and you can see here we have updated it. Previously we have drawn a rectangular, now we have imported a shapefile. So you can have a look at this shapefile. If I click on here, you can find the shapefile's location and how it is. Now let me close it. Now let us begin the process. I have done nothing, just imported this study area file. shapefile, and rest of the thing will be remain intact. We don't have to change anything. Okay, right? Now just calm down. Now let's just run the script once again, and now you can see the results how it is. Like this also you can generate the DEM for your study area. You can download it directly. So now let us look into it. In the taskbar you can see SRTM DEM 30 meters, that you can find the name from here, the description what we have given. So if you just click on run, the image will be exported. Now in this case you can see here we have already specified the drive folder name, so we don't have to do anything. If you want, you can customize the names for the SRTM, that is the output file. If you want, you can change it. So you can see here I used the GOT for the file format, exporting file format. Now click run, and you can check the status in the taskbar. So you can see here it is been processing. Once it is done, we can have a look at it. So once it is done, you can see a tick mark will be coming up. You can just open it, and you can click on open in drive. So now you can see here we have created a folder called as GE exports. Inside that our DEM data will be there. So click here and download it. You can see here the file has been downloaded. It is around 6.2 MB. Let us visualize it in a GIS software. Now let us open the org catalog. Here you can find the NASA SRTM 30 meters file which we have downloaded. So right click on it and move on to properties, and here in the no data value click on edit, and let us compute it. So you can see here 32761 is the no data value. Make it to 0 and click OK. Apply it, click OK once again. So when you are done, once again go to add data. From here you can just add the SRTM, NASA SRTM DEM. Now you can see here, have a look at the output. If you want, you can also change the color scheme for this. So I'm going to choose this color scheme for it. Click OK. You can see the elevation of the region. These are highly elevated region, and this is a low elevated region coming around 150 meters, and the maximum height is 2522 meters. So if you find this video useful, please do comment on it. If you like the video, please do mention it by giving us a like and subscribe to the channel. Thanks for watching. Bye.